Hello learners, wishing you a very nice day to all of you. Today we are going to start with Binomial Probability Distribution, Standard 12, Maths 2, Bernoulli Trials, Binomial Probability Distribution and Mean and Variance of it. Okay. Dichotomy. What is a dichotomy? Dichotomy deals with the only two possibility of any event. Like for example, whether I'm going to get the train today or not, I'll be reaching on time or not. Okay, today I'm going to meet my all targets or I'm going to miss them. So that means every experiment is dichotomous in nature. For example, today lecture is there or not there. Rainy season will be good or bad. Student will pass or fail. A candidate will get job or will not get the job. That means every experiment we can name one outcome as success, the other outcome as failure. For example, tossing a coin, if the occurrence of head is considered as a success, then occurrence of getting a tail is a failure. Bernoulli trial. It is the trial which has only two possibilities, that is success and failure. The outcome of any trial is independent of the outcome of any other trial, and the probability of success and failure remains constant for all the trials. So here we define what is Bernoulli trial. Trials of a random experiment are called Bernoulli trials if they satisfy the following conditions. That is, each trial has exactly two outcomes, success or failure. And probability of success remains same in each trial. Probability of success will be denoting by small p and probability of failure will be denoting by small q. For example, consider throwing a die and we define success if I'm getting a score more than 4. So obviously getting score less than equal to 4 will be a failure. So what is the probability of success for me? That will be if I'm getting score 5 or 6, that means 2 out of 6. The probability of success is 1 by 3. Probability of failure may be the score 1, 2, 3, 4. That's 4 out of 6, so it's 2 by 3. If a die is thrown 5 times and the score greater than 4 is required 3 times. So here the trial is throwing a die and success is 1 by 3 and 2 by 3 is the failure probability. We already discussed this earlier. Now, n is the total number of trials. So here it is 5 and success we require is 3 times, that's our x. Now out of 5 trials we need 3 success, that means failure will be 2. And how many possibilities are there? So it was 3 out of 5, that's 5C3, so total 10 possibilities like this, right? So now what is the probability of 3 successes? It will be 10 possibilities and then probability 3 times and probability of success 3 times and probability of failure 2 times. So it's 10 times 1 by 3 raised to 3 and 2 by 3 raised to 2. So here now we are getting ready to get the formula. In case of x successes, obviously there are n minus x failures. So probability, sorry, the x successes can be obtained and out of n is n factorial upon x factorial n minus x factorial, that's ncx. X successes and n minus 1, n minus x failures will be p x times and q n minus x times, that's p raised to x, q raised to n minus x. So here's our formula. Probability of getting x successes in an n Bernoulli trial is n factorial upon x factorial n minus x factorial p raised to x q raised to n minus x, that's ncx p raised to x q raised to n minus x. Binomial expansion, yes, the term reminds you the formula for binomial expansion of p plus q raised to n. That was summation k from 0 to n nck p raised to k q raised to n minus k. That means for any experiment of n Bernoulli trial, the probability of getting 0, 1, 2 or n successes can be obtained as first, second, third or n plus 1th term of the binomial expansion of p plus q raised to n. Probability of x successes out of n trial is ncx p raised to x q raised to n minus x. That means probability of x successes gives you the x plus 1th term of the binomial expansion of q plus p raised to n. Binomial probability binomial distribution gives you the distribution for every x corresponding probability. So if x takes the value 0 to n, corresponding probabilities are given as the terms of the binomial expansion like nc0 p raised to 0 q raised to n minus 0. For 1 it's nc1 p raised to 1 q raised to n minus 1. For 2 successors it's nc2 p square q raised to n minus 2. In general, x successors is ncx p raised to x q raised to n minus x and so on up to n successes. Probability binomial distribution is known binomial distribution with parameters n and p. It is represented as x following binomial distribution with n comma p. They are the parameters, and formula for x successes is ncx p raised to x q raised to n minus x. X takes value 0 to n, that is total n plus 1 values. The relation between p and q is the sum is 1. Now to solve any problem, first you make out what is the single trial consider in the example. Then find the corresponding probability of success and failure for the single trial. Check the number of times the trials are being repeated, that will be n, and decide the number of times success required, that will be x. Let's consider now few examples. Exercise 8.1 first sum. A die is thrown 6 times and if getting an odd number is the success, find the probability of 5 successes, at least 5 successes, at most 5 successes. Okay, so first let's find out the answers of following questions. First one, what is the trial considered here? So it's what? Throwing a die, right? What is success in this case? What do you want in this is a number, getting an odd number is the success. What is the probability of success? Odd numbers from 1 to 6, there are 3, 1, 3 and 5. So probability of success will be 3 out of 6, that's 1 by 2. How many times the trial is being repeated? It's 6. And what is the value of Q? Q is 1 minus P, so that's half again. So now first we'll generalize the formula which is applicable for this example. So repeated throwing of a die are Bernoulli trials, x be the number of successes in the experiment of 6 trials. So x follows the binomial distribution with n and p, with n is equal to 6, p is half, and obviously q is half. Formula becomes ncx p raised to x q raised to n minus x. After substitution of n, p and q, it simplifies as 6ex 1 by 2 raised to 6. Okay, now let's solve the first one with 5 successes. That means we want exactly 5. So x is 5 in this case. Substitute x is equal to 5 in the formula and we get the answer. Quite simple, right? So it's 3 by 32. Very good. Second one, ask for at least 5 successes. What does that mean? X can be more than equal to 5. That means x is greater than equal to 5. Okay, so x can be 5 or x can be 6. So we have to add the two probabilities of 5 successes and 6 successes. Substitute the formula with x value 5 and y 6. So you get the answer as 7 by 64. At most 5 successes. Here we mean the maximum of 5. Okay, so x is less than equal to 5, but here x greater than 5 will be easier to count, so we go for complement. It will be 1 minus p of x greater than 5, that is x is equal to 6, and the answer comes out to be 63 by 64. Clear? Good. Let's move to the next example. There are 5% defective items in a large bulk of items. What is the probability that a sample of 10 items will include not more than one defective item? So first decide what's your trial here. It's selecting n item out of a large bulk of items. Okay, probably what is the success in this case? Selecting a defective item because we are asked to find the probability of defective item. What is the probability of success here? 5%, that's 5 out of 100. 1 by 20 is the value of p. Q is 1 minus p, that comes out to be 19 by 20. It's being repeated for 10 times. You're going to select 10 items. So n is 10. Probability of x success will be ncx p raised to x q raised to n minus x. After substituting the values of n, p and q, we get 10cx 1 by 20 raised to x, 19 by 20 raised to 10 minus x. That's the formula which will be used for this problem. So here x is less than equal to 1 because we don't want more than one defective item. So it will be either 0 or 1. So it's going to be addition of probability of 0 successes and 0 probability of 1 success. So substituting x is equal to 0 in one case and x is equal to 1 in the other case. We add the two probability. The answer comes out to be 29 by 20 into 19 by 20 raised to 9. Clear? Good. Next example, in a box of floppy disk, it's known that 95% will work. A sample of 3 are to be, of the disk are to be selected at random. Find the probability that none, 1, 2 or all 3 of the sample will work. So decide what is your trial here. You're selecting a floppy disk out of the collection. What is your success here? Selecting a working disk, a nice, good working disk. Probability of success is 95%. That means 95 out of 100. 19 by 20 is the probability of success. That will be P, and Q is 1 by 20. N is equal to 3. So probability of X successes after substituting N, P and Q is 3CX, 19 by 20 raised to X and 1 by 20 raised to 3 minus X. Okay, now we discuss all the subsums. First one, none. That means x is 0. 0 successes. Probability will be 3C0, 19 by 20 raised to 0 and 1 by 20 raised to 3 minus 0. That comes out to be 1 by 20 raised to 3. X is equal to 1. We substitute x is equal to 1 in the formula. We get the answer as 57 into 0.05 cube. N is equal to, x is equal to 2 successes given by here substituting x is equal to 2 in the formula, we get the answer as 0.15 into 0.95 raised to 2. All three good working disk, x is equal to 3 and the answer comes out to 0.95 cube. Okay. Next one, find the probability of throwing at most 2 successes in 6 throws of a single die. So what is the trial here? Throwing a die. Success is getting a 6, the highest score. Probability of success is 1 by 6, Q is 5 by 6, N is 6, X is 2. You require 2 times success. So probability of X success is NCX P raised to X Q raised to N minus X. After substituting the value of N, X, P and Q, We get the answer as 5 by 12 into 5 by 6 raised to 4. Now we are ready to discuss about mean, variance and standard deviation. If x follows a binomial distribution with the parameters n and p, the mean or expected value, the average value, is given by mu or ex is equal to n times p. Variance is denoted by VAR of x where of x given by npq. Standard deviation of x is denoted by SDX or sigma. It's given by square root of variance of x. Now if x is given that it is following the binomial distribution with parameters n and p, let's consider a few examples. If you are given few values and find the other. First case, you are given n is equal to 10 and p is equal to 0.4. Find ex and where x, variance of x. Formula, first we'll find out what is q because you are given n as 10 and p is 0.4. So first q is coming out to be 0.6. E of x is n into p, 10 times 0.4, that gives you 4, and variance of x is npq, that's 2.4. Second case, p you are given and ex you are given. Find the value of n and variance of x. So obviously here p you are given, so you can find out what is q and then go for the formula of ex, n into p. From that we get n is equal to 10. Variance of x is n into p into q. We have all three values, substitute, get the value answer as 2.4. Third one, you're given n and ex and you're supposed to find p and standard deviation of x. So first formula, ex is 10, which is n into p, that is 25 times p. P is 10 by 25, that comes out to be 0.4. Now value of q, and then Vx is npq, that's 6. So obviously standard deviation is square root of variance, that is root 6. Fourth sum, if n is 10, ex is 8, find the variance of x. It's similar to the previous one. N is 10, ex is 8. So from that you get the value of p, 0.8, q, 0.2, and then variance is n into p into q. That's 1.6. Now let's try some miscellaneous exercise sums. If x is a following binomial distribution with n is equal to 10 and p is 0.2, find the probability of x is equal to 1, x greater than equal to 1, and x less than equal to 8. So here we have n as 10, p as 0.2, q will come out to be 0.8. First generalize the formula. Probability of x successes is 10cx, 0.2 raised to x, 0.8 raised to 10 minus x after substituting n, p and q. Now first one is x is equal to 1. So here we are going to substitute x is equal to 1 in the formula, 10c1, 0.2 raised to 1, 0.8 raised to 9. That gives you the answer as 2 into 0.8 raised to 9. For probability of x greater than equal to 1, it's easier to calculate probability of x less than 1. So we go for complement, that's 1 minus p of x less than 1. That's 1 minus p of x is equal to 0. After substituting x is equal to 0 in the formula, we get the answer as 1 minus 0.8 raised to 10. The third one, probability of x less than equal to 8. Here again we go for complement, 1 minus probability of x greater than 8. That remains only two probabilities, that is either x is 9 or x is 10. So we subtract the sum of the two probabilities from 1 minus probability of 9 successes and 10 successes. So here the answer comes out to be 1 minus 8.2 raised to 0.2 raised to 9. A fair coin is tossed 10 times. Find the probability that it shows heads 5 times. And second one is you want heads for first 4 tosses and tail for the last 6 tosses. Trial is tossing a coin, success is getting a head. So probability of success and failure both are half and n is 10. Now, first we'll write down the formula which is applicable in this sum. 10cx half raised to 10 after substituting the values of n, p, q. First case is you want success 5 times. So obviously x is 5. Just substitute and get the answer as 63 by 256. Now second, you want four heads and tail for the last 6 tosses. That means you want success, 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 success 4 times. Failure, 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 failure last 6 times. So it will be, you're thinking of only one possibilities. Okay, so that will be p raised to 4, q raised to 6, half raised to 10. That means 1 out of 104. Next up, a large chain retailer purchases certain kind of electric device from manufacturer. The manufacturer indicates that the defective rate of the device is 3%. The inspector of the retailer picks 20 items from a shipment. What is the probability that the store will receive at most one defective item? So here what is the trial? That means you're selecting one item. What is the success? The picked item is defective. So probability of success is 3%. So it's 0.003. Q is 0.97. N is being 20. Formula, probability of x success will be 20cx, 0.03 raised to x, 0.97 raised to 20 minus x. So you want probability of x being less than equal to 1. So it is either 0 or 1 successes, addition of the two. After substituting x is equal to 0 and x is equal to 1 in the formula, we get the answer as 1.57 into 0.97 raised to 19. Clear? Yep. Yes. This is the answer sheet of many competitive exams. So in an examination consists of 10 multiple choice questions, in each of which candidate has to deduce which one of the 5 suggested answers is correct. A completely unprepared student guesses each answer randomly. What is the probability that the student gets 8 or more questions correct? Draw the appropriate moral. Yeah, this happens many times. We are unprepared and we ask for undeserved success in our prayers, right? Okay, so what trial here now? Trial is candidate guesses an answer of given question. Success is the guessed answer is correct. So probability of success is P, that's 1 out of 5. Q is 4 out of 5. N is equal to 10. Now formula NCX, P raised to X, Q raised to N minus X. We substitute the value of N, P and Q. Now we want probability of X being greater than equal to 8. So there are 3 possibilities: 8 successes, 9 successes, 10 successes. So addition of the 3 gets you the result as 761 divided by 5 raised to 10. So what is the moral? Always give exam with good preparations. Don't ask for any undeserved successes. That's not possible, right? Okay. The probability of success in a single trial is 0.01. How many trials are required in order to have probability greater than 0.5 of getting at least one success? Now see here, we are not given what is a trial. Okay, we are given only probability of success, that is P is 0.01. So immediately we'll calculate what is Q, that is 0.99. Okay, now we are not given the value of N, so let the number of trials be N. Now we are given that probability of getting X successes greater than equal to 1 has to be greater than 0.5. So here on substitution of the value of X and P and Q, we get 1 minus NC0, 0.01 raised to N, 0.99 raised to N. This quantity has to be greater than 0.5. That means NC0, 0.01 raised to 0, 0.99 raised to N has to be less than equal to 0.5. So taking log, we get N times log 0.99 less than equal to log 0.5. The base can be anything, either E or 10. N has to be greater than equal to log 0.5 divided by log 0.99. Now see here the inequality sign has changed. You think about the reason? Yes. So solving this, you get the value N has to be greater than equal to 68. Last sum. In binomial distribution with 5 Bernoulli trials, the probability of 1 or 2 successes are 0.4096 and 0.2048 respectively. Find the probability of success. That means we are not given P, we are given N as 5. We are given probability of success of one success and probability of 2 successes. Let probability of success be P and probability of failure be Q. So probability of X successes is 5cx, P raised to X, Q raised to 5 minus X. We are given probability of 1 success and probability of 2 success. Just substitute in the formula. We get two equations. 5 times P into Q raised to 4 is 0.4096. 10 times P square Q cube is 0.2048. So dividing the two, we get the value of Q by P as 4. So Q is 4 times P. Also we remember P plus Q is 1. So substituting in that, we get the value of P as 1 by 5. I hope you have enjoyed the session and thank you very much.